Hi students, we're going to look at powers and exponents. We're actually simplifying exponential expressions. And so you probably know that an exponential monomial is a base to a power, a base b to the power n. So this would be b to the nth power. If you had 3 with a 2 exponent, that would be called 3 to the second power, or 3 squared. If you had, for example, 4 to the third, you would call that 4 to the third, or 4 cubed. Let's say 5 to the 7th, we would call that 5 to the 7th power. So that's how you say those terms. And notice all those were one base to a power. Those were what we call monomial. These are results. Well, let me start with this. Suppose I gave you 5 to the 4th power and I asked you to evaluate that. I highly suggest for the first week that you actually expand that, what we call expand, which is 5 times 5 times 5 times 5, because there is this tendency to multiply 5 times 4. That's repeated addition. 5 times 4, can I show you? This is 5 times 4. Right? Or you could say 4 5 times. 4 plus 4 plus 4 plus 4 plus 4. In both these cases, the answer is 20, and it's repeated addition. But when you're working with exponents, that's repeated multiplication, and it's a little hard to get used to. So, of course, this is going to be 25 times 25, which is 625. So this is, if you're asked to evaluate it or to write it as a monomial and you're given a base to a power, this is how your response is. And again, I highly suggest that you write out your terms for today. Okay, for the next week. Suppose they give you a variable like a times a times a. This would be expressed as a is your base to the third. If you were given negative x times negative x, okay, we call this quantity negative x because it's what's in the parentheses. So you need to keep it in the parentheses, negative x, quantity to the 4th power. All right, and the reason why let me get into the negatives. The reason why I accentuate that is this. If you had, let's say you had negative 4 squared and you had negative 4 quantity squared. Oh, yuck. Don't know what happened. Because of PEMDAS, please excuse my dear Aunt Sally, which says parentheses first, then exponents. Because of PEMDAS, in this case, you have to do the exponent before you multiply by that negative 1. Putting a negative in front of any quantity is the same as saying, I'm going to multiply this by negative 1, or I'm going to find the opposite of this number. You have to do the exponent first. This is negative 16. This, on the other hand, could be re-expressed as negative 4 times negative 4. And you know that a negative times a negative is a positive. So this is positive 16. If I were you, I would write this down. This part is pretty important. It does happen on your worksheets. It's going to happen on a quiz. It's going to happen on a test. Everybody does this to make sure that you understand that this is negative because you're doing the exponent first. This is positive because the quantity that you're squaring is the entire negative 4. Okay, and another thing. Suppose that you had a coefficient in front of an exponent. Let's say you had 2 times 3 squared. PEMDAS comes into play again. You have to do the 3 squared before you multiply by 2. This is the same as 2 times 9, which is 18. And as you can probably tell, if you do the 2 times 3 first, then that would be 36. 6 squared is 36. Not even close. So please understand that whenever they do not give you an exponent, you can assume it's 1. That's 2 to the first times 3 squared. 3 squared is 9 times 2 is 18. And something else to add to your notes, if you have two quantities, like let's say 3 squared times 9 squared. If you are multiplying, not adding, but multiplying, you can, if you want to, take 3 times 9 and square it. 3 times 9 is, of course, 27, and 27 squared, I don't know off the top of my head. So let me show you why. If this is 3 times 3, and this is 9 times 9, isn't it true that multiplication is commutative? Isn't this the same thing as 27 times, I'll put this 3 with this 9, 27. And it is, because of the commutative nature of multiplication. Notice it does not work if your exponents are different. Let's say it's 3 squared times 9 to the third. You can't do 27 to the 6th because this is 3 times 3, 9 times 9 times 9. You're multiplying those together. There's really no way to simplify that. I mean, there is, but it would be far too confusing. You're better off just do 9 times 729. Now I want to talk about the word monomial. When you're talking about polynomials, that includes what we call monomials, binomials, trinomials. I know that's kind of, and I'll do a video on that all by itself, but we're working with monomials today. When you're trying to simplify, that mono means one. So every number is a term. This is a term. This is a term. This is a term. This is a term. They're variables, but they represent a number, so they're terms. Terms are numbers or values that can be separated with plus or minus signs. If I put this together, I could put 3.5 together, right? 3.5 plus A plus B plus X. And that's 1, 2, 3, 4 terms. So it's not a monomial. There's a polynomial. There's several terms there because they can't be combined because there's a plus sign between them. However, let's say that I had b squared times, x squared times 4 squared. This can be combined to one monomial because there's no plus or minus there. Now I need to put my number first. This would be 4 squared, or you can write 16. So numbers go first, and then your variables. And your variables should be alphabetical, like that. This is considered one term, a monomial. So if you're given stuff that's being multiplied together, go ahead and simplify it into one monomial. Okay, you take care.